Now let's look at multiplying complex numbers together. We're going to multiply a complex number a by a constant term c, and we're also going to multiply two complex numbers together, that is complex number a and b. So first of all, let's look at multiplying a complex number by a constant. We're going to have a times c, which is going to be 2 times 2 plus 3i. So we multiply out the terms, and this gives us 4 plus 6i. So we will look at this in our assembly language in just a moment. But we also want to be able to multiply two complex numbers together. So we're going to multiply the number a and the number b. So it's 2 plus 3i times 3 plus 4i. And again, we multiply out the brackets. So we have 2 times 3, which is 6, 2 times 4i, which gives us 8i, 3 times 3i, which gives us 9i, and 3 times 4, which is 12, and I times I, which is I squared. So the 8i plus 9i will give us 17i. The term I is the square root of minus 1. So the square root of minus 1 squared is the square root of minus 1 times the square root of minus 1, which is a value of minus 1. So finally this is going to give us 6 plus 17i plus 12 times minus 1. So this is going to give us minus 12, and we will finish up with minus 6 plus 17i. So whenever we work through this example here of a times b, it's a little bit more involved, but all we have to do is make sure we multiply out each of these four terms together, and then we negate the term with the I squared. So let's go ahead and we will see these in our assembly language. On the right hand side we have the calling function, on the left hand side we have the subroutine. In the calling function we have the complex number a, which is 2 plus 3i. We're going to multiply it by the scalar, which in this case is a value of 2, and we're going to save the value in complex b. So we have set aside two memory locations, one for the real part, one for the imaginary part. We then push the complex number a, we push the scalar, and we push the complex number b. Remember, whenever we're pushing these, we're pushing the start addresses of these. We then jump to the subroutine. It runs through the subroutine and it returns the values into complex b, and that's it finished. So let's look at the actual subroutine. We're going to push the values of the registers into temporary storage locations. We're going to pop the return address, and then we're going to pop complex b, pop the scalar, and then pop complex a. And we pop these into registers R4, R3 and R2. We're then going to work out the real part. So we load R2 into R0. So it means that R0 is going to have the real part of the complex number. So it's going to have this number 2. We then load R3 into R1. So R3 contains the scalar quantity. So we're loading the value of 2 into R1. When we multiply them together, we're multiplying the 2 times the 2, and then we store it in the address R4. So that's has worked out the real part of the multiplication. We then go ahead and do the imaginary part. So to do this, we're going to have to shift or increment the value. So we want to pull out now the value 3, and we also want to save it in the next address of complex b. So this is why we use the increment R4, increment R2. So we can then go through the same process as above. We load R2 into R0, R3 into R1, we do the multiplication, and we store the value in the address pointed to by the contents of register R4. And that's us done the 2 times the 3, and that's us finished. We go and we retrieve the original values for the registers, and we jump to the return address, and that ends up here. So that's the first part, which is multiplying a complex number by a scalar. Now let's look at multiplying the two complex numbers together, and it's a little bit more involved. On the right hand side we have the calling function, the left hand side the subroutine. So in the calling function we have the complex number a, which is 2 plus 3i. We're going to use the same values that we've seen in the previous example. And we have the complex number b, which is 3 plus 4i. And then the solution to the multiplication is going to be held in complex number c. So we're going to push complex number a, b and c onto the stack. We then jump to the subroutine. We then come into the subroutine here, we run through the multiplication and it returns the values into complex C. So let's look at the actual subroutine. So in here we store the values for the registers, we pop the return address, and then we pop complex C, B and A into registers 5, 4 and 3. We then clear off this register 2 because it could potentially have a value in it. And we work through these 4 options. So you can see here option 1, and then we've got 2, and then we've got 3, and then we've got 4. Now all that happens within these options, if I bring this up here, all that happens within these options is that it multiplies each of these values in turn. So what it will do is it will multiply 2 and 3, and it will store it because that's the first part of the real number. Now the next part of the real number will occur whenever we multiply the 3i and the 4i. So you can see here when we multiply the 3 and the 4 we get the 12, and the I squared will give us the value of -1. So that will give us -12. So we add the 6 and the -12. So the multiplication of those two will have to be added together. So that's the next part that we do here. Okay, so the first part here is multiplying the 2 and the 3. The first part here is multiplying the 2 and the 3. The next part here is going to be multiplying the 2 imaginary parts and then adding both of those together. So that gives us the final real value. And then we have to do the same for the other 2 options. So the other 2 options are going to be the 2 times 4i and the 3 times 3i, and then we add both of those together, and those will be saved under the imaginary part of the answer. So I'm not going to talk through the individual cases here. It follows through the same routine that we've seen in previous videos of loading a value into memory and loading the other value into memory and then doing the multiplication, storing it, and then going on to the next one and doing the same and then adding them together, and then moving down to option 3 and 4 and doing the same. And then we return all of the register values back to the original values, and then we jump to the return address, and this is return address up here, and the program ends. So if you're unsure of the code, you can always run it on the machine and you can follow every single 1 and 0s throughout the entire process of running it in the machine. So let's go ahead and we will see it actually running now. The example that we're going to look at here is the multiplication of the 2 complex numbers. So we're going to look at the 2 plus 3i times 3 plus 4i, and this should give us -6 plus 17i. So let's run this up now. Now we'll see the numbers dropping in here, and it should take only about maybe 20 or 30 seconds in order for it to work through, and you can see the numbers dropping in. And that's it, finished now. So let's go ahead and we will look at the solution here. So if we head down to 500, you can see the original numbers, 2 plus 3i and 3 plus 4i. And the final answer is -6 plus 17i. So we can see the FFFA is -6 in 2's complement, and the value 0011 is 17 in hex. So it does work and it goes through the multiplication. So that's us finished for the moment on complex numbers. We will move on in the next videos and we will look at manipulating strings. So in effect we're generating a string library. So thank you for listening. I'll get you on the next video. Goodbye.